Three of the following would be ample information to deduce that ABCD is a parallelogram. One is not. Which one is insufficient? Triangle APD is congruent to triangle CPB. This is, because that would mean that we have some pairs of matching congruent sides here. So this side would be congruent to this side, and we would have AP is congruent to CP, and we would see that PD is congruent to PB, which would mean that the diagonals bisect each other. Therefore, this is a parallelogram. So let's move on to the next one. I'm going to delete these markings. Okay. AB is parallel to DC, and AB is congruent to DC. This is enough information to deduce that this is a parallelogram. When opposite sides are parallel and congruent, you have a parallelogram. So no matter what this looks like, if this was even more extreme, say the sides were like this, they were the same length and they're parallel, that would mean that the opposite sides are still parallel to each other and congruent. So yes, this is enough information. Let's move on to the next one. Delete the markings. Okay. BC is parallel to AD, and AB is congruent to DC. This is not enough information because we could come up with another example of a parallelogram or of a quadrilateral with this information that's not a parallelogram. So for example, these are parallel, these are congruent. So it doesn't say anything about these being the same length, but we could have AD like this, we could have BC like this, and these two, AB and DC, could still be congruent. They're the same length. So this would be congruent to that, and we have this parallel to this. This is not a parallelogram, but it does satisfy these conditions. Therefore, the answer to this problem is C.